every place you come across has a different way of doing it. And it is definitely that if you have specific rules or principles and you try to apply them, they probably work the first time you build the software because it's nice and clean. But then as soon as you then try and expand the software, maintain the software, add new features into the software, you get into this horrible world of, well, do I break the principles to achieve what I want to do, or do I spend much longer ripping everything apart to insert all the new stuff and maintain the principles again?
I'm Jason Harmon, and this is API Intersection, where you'll get insights from experienced API practitioners to learn best practices on things like API design, governance, identity, auth, versioning, and more. Welcome back to API Intersection. So I'm not going to say the thing I always say, that we're going to do something different, because it's always different, right? I'm reminded every day lately that APIs are everywhere now. I mean, if you can touch something, there's probably an API for it. You just haven't turned it on yet. So from the UK, joining me today is Chris Turner, who's actually writes code for a living, which I have to point out is somewhat unusual for our guests. So Chris, thanks for joining, and tell us a little bit about yourself.
Hi, I'm really glad to be here. So I'm a software engineer in the UK. I'm still 25 years into my career. My main goal is writing code. I love writing code and designing systems. Worked across a range of domains, from everything from sort of travel reservation, telecoms, media, e-commerce, green tech. But currently I'm working for a really niche UK bank called Crown Agents Bank. And we're sort of a specialist bank that specialise in moving money in between countries, particularly moving money from the developed world into developing countries, particularly in Africa, and using sort of computer systems and joining up all the APIs and all the various systems to actually make those payments into countries where that money really makes a difference.
Yeah, it's super interesting. And I couldn't help but notice on your profile, you've been working on this API stuff for quite some time. And it's like I was saying, they're everywhere now. So yeah, you end up learning a lot of different things. I guess when you look back at all these different domains, all these different kind of industries, where is that kind of taken your thinking when now you're in fintech and banking, which I have some experience with, and it's pretty different, but do you feel like there are sort of portable things from that you're now more focused on in implementing this?
Yeah, definitely. I think over the years I've been through, again, all the standard things like the journey through SOAP and all of those things, and still see this thing that everyone sort of kind of like creates their own API, and each API is subtly different to every other API, which always makes a fun integration challenge. And particularly sort of what we're doing at Crown Agents Banks, we've got lots of legacy banking systems, modern banking systems, and we're also often integrating into banks and mobile network providers in Africa, which have, again, a variety of different levels of sophistication on their APIs. And just looking at that started to get us thinking around, well, how can we try and create a common view of all those APIs without sort of trying to aggregate them all together, because that's never going to happen. We've just got such a diversity. And my experience over the years has always shown that it's sort of trying to create generic APIs has never really worked. I've always found that what you end up with is either a horrible giant mess, which is really difficult to deal with, or something which is like the worst of all the worlds. So what we started to look at is let's try and focus these APIs around particular domains, and then use some sort of the software engineering techniques that we use to build good software, and see how we can apply them into sort of the world of APIs that we're building.
Yeah, it's interesting because I feel like when I look at you mentioned like aggregation and the idea that you can come up with like the perfect API for a given vertical. I'm old enough, and I guess you probably are too, to remember like the days of Oasis and SOAP, right? And we saw these industry groups get together and say, well, let's all agree between all these different huge companies as to what the spec should be. And by the time they're done, no one wants to use it because it's like, 50,000 fields to do anything. But it's interesting to see these days there's more and more of these kind of aggregation platforms that are trying to make it easier and that sort of thing. But I'm kind of with you. It seems like a fleeting goal that is diminishing returns over time.
Yeah, I've definitely found particularly my previous role, I worked in sort of green tech energy, and we were integrated with a lot of energy APIs, and there were lots of developments of standards for sort of grid management and things like that. But every new provider that came in with something different, add a bit to it, add a bit to it, and you sort of end up with a core and all these little extensions that go off of it and various profiles, and it actually becomes such a big blob of stuff to try and get your head around and implement. It would have been so much easier just to have half a dozen very simple APIs. That the understandability of that, I find, would be a much greater sort of. It's easier to understand, easier to build than trying to sort of create something that requires a massive amount of code with lots of conditional statements, which is hard to test and likely to have a lot more bugs in it.
Yeah, it's an interesting facet of what you're doing here, and having some prior experience in fintech in my time at PayPal. Um, one of the like American perspective things that I learned was the whole world doesn't use credit cards to pay for stuff. And certainly, like I was more involved with Japan, but was aware of Africa that like mobile phone based payment is the way. And so, I would imagine connecting with all of the different sort of telecom providers and all that sort of stuff, which in that market, it's text based payment, right? So super foreign and seems like impossible to secure. But so I'd imagine your perspective on consumption here is somewhat different too, which is partially the way you're describing this problem.
Yeah, it's effectively, yeah, every single provider that we potentially connect to has got a. They're very similar because they're all trying to do mobile payments of money when we're moving sort of small amounts into people's mobile accounts, but they all do it in a subtly different way. And we still got some customers, some providers that we integrate to where are still using portals, and we actually have to web scrape them, so they're not even on the API journey there yet. But a lot of them are APIs, but there are lots of sort of XML based APIs and things like that. And they're all very subtly different in terms of exact IDs and how they represent sort of particular data. So it's kind of quite hard to aggregate all of those into a common approach. So we do tend to end up with a core, but sort of specific implementations for each provider that we're actually connecting to for that.
Yeah, and connecting with that many providers, I mean, beyond, I guess, I would venture to guess you've got sort of an internal representation of how to aggregate those things that, you only use for your own implementation. But how do you look at sort of the resilience of having to connect to all those different things, which I could imagine in a developing market like Africa, you might have things that go up and down, and they might be a little shakier than in some other parts of the world.
Yeah, that's absolutely. We have a lot of the core implementation of our code is around sort of strategies for dealing with sort of retry mechanisms, back off mechanisms, and we even have some providers who, for example, we might have a single account that we have to log into, so we can only make payments sequentially. So therefore, we've then got sort of back off queuing mechanisms and sort of semaphores in that we have to kind of create that actually prevent access. So multiple payments don't try and process that, putting everything in queues. So it's a whole sort of gambit of different things that we have to sort of think on top of rather than just the protocol that we send as well.
Great.
It makes it fun.
Yeah, for sure. I think you just won for new term on API intersection, semaphore. So congrats. I don't think I've ever heard anyone mention it before. CS stuff most people forget about.
Yeah, those core techniques are still they're still out there. They're still there under the covers.
Absolutely. So on all this kind of resiliency stuff, are there specific sort of tools that you've used that have made this easier to deal with in terms of all the back off and all these things you're talking about, or is this all bespoke?
There's a lot of bespoke stuff, but quite a lot we use a framework. So taking from sort of like the world of domain-driven design, one of the sort of concepts in there that you may have sort of come across is called CQRS, Command Query Responsibility Segregation. So in the theory, you're having effectively a stream of events, which is your event source, which is your source of truth and your timeline. and then from that you process the events and create various views and things. So we kind of tend to make use of that. So there's a particular framework, Axon framework, which is an implementation of that, which is very good, and it contains lots of useful technology for like timing events, setting retry events to trigger at some point in the future. So we can sort of send off a message asynchronously, wait, and if it times out, we can then schedule a retry event to occur at some point in the future to try again. And we use that to also schedule events around managing resources and the back off of there. So kind of using that sort of that audit trail of all the transaction history through, that we can actually use that, and then everything is then an event coming back in to trigger sort of the next stage or the retry, or some kind of building queuing mechanism to stack that up. So it's sort of a lot of bespoke, but building on sort of some standard core sort of modeling practices that have been proven over a number of years.
Yeah, I feel like that it's a thing that always comes up. I'll say though, I feel like a lot of shops I've been in, I see folks fail at trying it. Like they get halfway and it's sort of like CRS or QRS or something. Like it's, kind of halfway done. But the dream is always that, well, we can replay this stuff in test, right? So have you realized the dream, and can you actually do these replay of log kind of stuff in test?
We're getting closer. We're definitely not there yet, but we're definitely at the point where we can collect the event source and we can replay the stream through. But we've probably still got a little bit of work to actually do that. And the real challenge is when most of the systems we're integrating to, a lot of them are very unreliable and unstable. So they actually, and a lot of them don't even have like test instances that we can use. So we can't replay those events against live services. So a lot of the work we're working on towards now is how can we actually create a simulation of those services that actually honors the same API contract, and then be able to replay the sequence of events against the simulation to test our software. But then can we use the stream of events then against the actual API to test that their system is still behaving in the way we expect it to? So we've definitely got a long way to go on there, but it's going to be a very good journey when we get there, I think.
Well, I'll say in our experience at Stoplight, when we see folks using mocking like you're describing, it's usually a good sign of a level of maturity and approach. It's not usually a thing people start with. They kind of learn about it over time. So that's a good sign. On events, I'm curious, and I suppose this is valid for the API side too. Are you using sort of spec formats to describe these things?
Yeah, we're just really starting to get into proper sort of API contracts and things and enforcing those. So particularly for our sort of our synchronous HTTP stuff, we're starting to get sort of open API contracts properly drafted for all those, so that we've got sort of something to validate, and creating them as well for the third parties that we're integrating, because most of them don't have that. They have some very flaky documentation quite often. So actually trying to sort of build some contracts for those as well.
You getting those PDFs in your email?
Absolutely, yeah. You've got to love that way of working.
It'll never not exist. It's always going to be a thing somewhere.
Yeah.
So Open API for the synchronous stuff on the event side, are you using anything in similar fashion for contract?
Not really at the moment. So that's definitely an interesting area to look at. But fortunately, we're at the point where most of the systems that we are integrating with tend to be synchronous, and they tend to be fairly unsophisticated in that we're polling them, because that's largely what they support. And most of our sort of converting that to sort of asynchronous events happens within our own landscape and our own microservices. So we're kind of largely in control of those, but definitely it's something we probably need to look at a bit more, is how we kind of define those and contract those events that are moving between the different sort of the different bounded contexts within our system.
Yeah, it certainly seems to be a growing trend of folks that are trying a more event-driven architecture, and it's like in the same way that you can kind of get this API sprawl with the synchronous stuff, where you lose consistency as scale goes up. The same thing happens with events. The upside being it seems to be predominantly internally focused, which it sounds like is your story here. So I guess, we've been talking a lot about all this stuff you have to consume to operate, but I guess if we shift back to kind of that internal focus, what do you do to kind of try to gain some kind of consistency with what sounds like a real patchwork of external connections.
Yeah. So what we've been doing is it's probably worth going back to sort of like 2004. Actually, is where my sort of journey on this started. And there's a chap called Eric Evans, and he wrote a book called Domain Driven Design, which is it's one of those classic books that even though it's sort of almost 20 years old, it's still everything in it is still relevant, just as relevant today as it was when he wrote it back all those years ago. Unlike the books about various frameworks which move and become obsolete, this is kind of like one of those core books that I go back to all the time. It's just got so much great material. So definitely recommend it for an investigation, a little read if you haven't sort of come across that. But one of his main concepts in there is that the domain is your focus. And what we discovered fairly quickly is actually within our world, there isn't just one domain, there are lots of different domains. And where we had in previous versions of our architecture, those domains had kind of like overlapped with each other a bit. So concepts from one had seeped into another. So weird cryptic field values or field names or data structures from, say, the banking domain had sort of seeped into the payments domain. And then as the banking domain changes, then the payments service suddenly potentially breaks, or you have sort of significant sort of breaks in API contracts between them. So what we've really been focusing and starting on this work is actually looking at, let's create a proper bounded context for each domain, define the domain model inside it of how this data is structured, what it looks like, how it integrates with all those services, but then focus really clearly on the contract that provides to other bits in our infrastructure, other domains. So have a very clean API model for that and a really clean set of events that we clarify and sort of document very thoroughly. And that's the way we're trying to keep that separation. So we can build those two bits independently, different teams, different speeds, but without allowing one to cross-pollinate too much into the other that causes that breakage.
Yeah, it's funny. I think sometimes people get really wrapped around the axle with DDD stuff, and I'm not saying you are, but I often have to kind of remind folks, just bring it back down to like the simplest thing is just single responsibility principle, right? Build a thing to do one thing. If it takes more than one word to describe it, you're probably doing it wrong, right? If you've got the and or the slash in the name of this capability or this API, right? Like take a step back. Is it really doing a single purpose? And you don't need to read a book to understand that idea either. It sounds like on kind of I'd imagine you have a lot of legacy things here. We were talking before, and you're saying this is like a 200-year-old company or something?
Yeah. It's originally a sort of a British colonial era bank that sort of evolved over time from sort of investing in these foreign countries, sort of part of the British Empire legacy, gone through lots of various changes, and now has sort of evolved into much more of it's a fintech with a banking history behind it. So it has a nice network of correspondence in sort of Africa and other countries all around the world. But actually, at the heart of the front, it's becoming more and more of a fintech in processing payments. But there are legacy banking systems in there with nice sort of XML based APIs. A couple of systems that we have to talk to where we actually just invoke stored procedures on a database because that's all that's there. And we're trying to sort of wrap those with APIs to make that much more integratable. But again, keep treating them in their own context so that the details of those systems, as they gradually move away and change over time and get replaced by newer systems, that we're trying to make sure that we don't build our new fintech stuff on that sort of foundation where we're tied to whatever those old services were. And that's where the domain modeling really comes in. Is let's define a domain for that we don't necessarily worry about exactly how it's implemented at the moment. We know we've got a new domain model that's backed by an old legacy system with a good public contract. And then as we strip away one of those old layers and replace it with a new layer, hopefully, if we've done the domain modeling right, working with the business to make sure we've captured all the concepts that they want, then we hopefully don't end up with that change of back-end system having to impact our newer sort of fintech payment engine.
Well said. Yeah, sometimes I see these threads where, it's like Reddit or Stack Overflow or something, and somebody's like, "Well, clearly you're doing it all wrong because you haven't all designed it all perfect." And having worked in some places before, like I worked at a place that was a like 60, 70-year-old manufacturing company, you realize like on a long enough timeline, there's going to be messes. And yeah, just having it's like dressing up the order taking window because nobody wants to take a tour in the kitchen, right? Like just make sure that that contract is clean, and then you can swap out the underlying implementation while you trim off all the capillaries of side loaded traffic, right? It's at scale, it's kind of the only way to do it. As much as idealists who haven't seen it might have other ideas. So I can totally respect that. I guess are there other aspects besides, and I know it's not exactly DDD a concept, but to me it is a single responsibility. Are there other aspects of that from a design perspective when you think about scaling out the future of the platform that you feel have been really powerful from DDD?
Yeah, definitely the sort of the whole context of a bounded context that we've got that isolation, and there are some really good patterns in there, sort of adapter patterns, which is how we're sort of managing, sort of talking to those systems. There's also really good stuff in there around what they call an anti-corruption layer, which is kind of quite good on the API world, which is all about rather than just taking the concept, taking the domain model that you've got in one domain. So say we've got a domain around core banking, so bank accounts and statement entries, we could ship that straight away over into our payments domain and build that on the same model. And actually it's, okay, we want to debit money from an account, credit money to a different account. But actually you're then bringing the concepts of one domain inside another, and that creates that sort of fragility between the two. So the sort of the anti-corruption layer in DDD kind of says, rather than doing that, what you do is you make sure that your banking domain exposes something which is meaningful to the payments domain, but not its internal details. And then when you bring that into the payments domain, we actually transform it from there into the payment domain model world and then manipulate it in there. So it's a transformation between one domain and another, rather than exposing the details of one into another across that API. And that then means that the two can move at different paces and develop as long as you maintain that transformation from one to the other. You actually get that you break that fragility pattern, which is why it's called anti-fragility. You break that fragility of changes in one place affecting another place. So that's something we've sort of really been sort of starting to focus on, is what is the core, again, the single responsibility of this domain to this other domain, and let's just encapsulate just the essence of that in those APIs.
Yeah, for sure. I don't know. Again, I feel like that whole how do you take a big, pile of interlaced things and peel them apart. This is well said that these are the ways to peel them apart. Another thing that you've mentioned in kind of some of your writing and stuff is this idea, this Cupid concept, which I'll admit, like news to me until about 30 minutes before we got on here. So tell me more. I'm intrigued.
Yeah, so yeah, there's a software engineer, sort of architect, sort of thought leader based in this sort of UK software development community called Daniel North, who's sort of quite well respected, written a few books, and he came up with this idea of based on looking at the sort of the original solid principles, which most sort of anyone who's worked in object oriented development should understand, sort of the basic solid principles. But he started looking at it a slightly different way: is how those are great for an engineering point of view, but they're almost like a set of rules where you have to follow them. And it's actually, why do you need a fixed set of rules that don't always apply to everything? So he started looking at for a different set of properties that you could use to describe software that's really good to work with, software that's actually joyful. His word is joyful. So software that's joyful to work with. And then we started looking at that as a bit more. It's actually, can those apply to architecture? Can they apply to APIs? And actually, they work really, really well to APIs. So his kind of view is, yeah, Cupid. If I go through the 5 terms, which is kind of the thing. So he's to focus much more on them rather than being principles or rules. They're more properties. They're slightly looser. They're kind of, you can evaluate where you are along the line. You don't have to be absolutely dived into this layer in the maximum detail. You can start at the other end and gradually move along the line of these properties, which is why they're sort of structured in that way. But yeah, so the five sort of properties of Cupid, and there's if you have a look on his cupid.dev website, it's actually a really good explanation. But the first one is composable. So this is about, rather than having an API, one API that does something and then another API which does something sort of in a completely different way, is make them so you can chain them together. So the outputs from one API should be, with a small transformation, the inputs to the next step in the workflow. So if you're building a workflow of multiple endpoints, you can just call, transform, and then with a sort of a common error handling pattern across them all, so that it's actually easy to just build a chain of APIs. And then if you want a different workflow, you can take out the certain endpoints that you don't need and replace them with different endpoints, rather than having to rebuild the whole lot with heavy weights of APIs from scratch.
Yeah, this is the Lego slide everyone sticks in their API talk, right?
Yeah,
That's what
absolutely.
it's
Yeah.
about. Plug and play different the common capabilities. Yeah,
Yeah, yeah, and the second one is he's called it Unix-like, which is kind of to make the Cupid acronym, but
I love it.
that is the single responsibility principle, and that whole sort of pipelining stuff together. That each endpoint should do one thing, and what you're actually trying to then do is build a workflow by composing all these little bits that do one thing together.
Well, and I have to call out from like the cupid.dev site. And for those not watching video, if you do, I'm tapping on my heart here that it's described as Unix philosophy, which this is like if you look across software in the last, I don't know, call it 50 years if you want, there's no single more successful thing than kind of the Unix philosophy of, if you try to write like a Linux or Unix command line thing, it's got to do one job real good. And if you embrace that in a design perspective when it comes to APIs, it just fits. Like, it just makes sense. But yeah, it is still ultimately single responsibility at its core, right?
Yeah, absolutely. Yeah. Yeah, and then the next one he's got is predictable. So this is one of my pet peeves on APIs, is where you call an API and it does one thing, and then you call it another time, and depending on some kind of state or some weird cryptic field value, that it does something completely different the next time you call it. And that's kind of the predictability. Is it should do the same. You should know what it's going to do, and it should reliably do that for you every single time.
Yeah, I would argue that like predictability in software engineering is pervasive. Like that, I mean, like you can ask the team at Stoplight, like first thing I did when I walked in the door a couple of years ago says we're going to get predictable as an organization. But that boils down through every layer of what you do. Like
Absolutely, yeah.
something should not have unintended side effects as much as you can prevent it, right? So, yeah, I love that
Yeah.
one. But go on.
Yeah, cool. And then the next one is idiomatic. So that's kind of just stuff should work in the way you expect it to work. And again, in the API world, another one of my sort of pet peeves is people adding all these sort of extra document elements to re-replicate the error handling that's actually built into the protocol itself, or sort of reusing HTTP response code in unexpected ways to mean different things than they actually do mean. It's like there's an idiomatic view of how APIs should work within particular protocols or within particular structure, and your API should stick to that.
Yeah, I won't go down the rabbit hole, but I will call out here that in the show notes that Bailey put together for Chris, it just said Chris hates GraphQL. So I'm going to leave that one there next to idiomatic, and we'll move on.
Yes, that's a whole other discussion.
Yeah,
isn't it?
it is. We don't have time. Maybe we'll have you back for that one.
Cool. And then the final element is sort of going back to the domain-driven design, which is domain-based. So the APIs, the stuff, the names of your APIs, the data structures in your APIs should be have a meaningful domain structure that's understandable to the business and particularly understandable to the client. And that's sort of one of the things we've particularly looking at. It's great if you build a really complex domain, but if the client can't understand that domain, then actually you've failed on the purpose of making that joyful for them to integrate to. It's domain based, but it's got to be a domain that structured in a way that the client can deal with it, rather than just the sort of the engineers who built it understand.
Yeah, I think it's part of why I tend to have a bit of an allergy to sometimes folks can be real ideologues with the DDD stuff because they're looking at it in this very modularity technical perspective. But like when I talk to product folks who are learning APIs, it's like this is about customer centricity. That's all it really is, right? If we had to describe our platform on a marker board with a room full of customers, would they be able to go, oh yeah, that's my stuff, I understand that, right? If you haven't
Yeah.
accomplished that, then you're just kind of bike shedding, aren't you?
Yeah, absolutely. And again, sort of another example from our sort of world is sort of sanction screening. So that we have to like for lot of these payments into countries, we have to check for that we're not sending them to people who are doing money laundering and things like that. And that's a whole other sort of that's a world of expertise. And actually, you can do that two ways. You can actually expose all the details of sanction screening into our payments domain and make it really complex that unless you're an absolute expert in that you can't really understand. Or we can kind of ship that into its own bounded context, wrap it behind some APIs, and actually the payments domain just needs to effectively know, oh, we'll send this for screening. Did it pass or not? And then that's something that the business and the clients of that can actually understand without having to deal with all the sort of the nuances of all the various different scenarios that it can fail in.
Yeah, it was honestly one of my single biggest learnings about my couple of years in fintech is that the real hidden game in that space, for people who get all zealot excited about, oh, we're going to solve this, it's going to be easy. So you got to be good at risk and compliance if you want to go global, and it takes at least a decade to figure out all those different markets and like, especially in developing markets. I mean, you're talking about like go into a window with paper to get stuff done sometimes. So yeah, I totally get that.
Yeah.
I want to reflect real quick though on this Cupid thing. I'm totally enamored. That's probably just because it said Unix philosophy and it sucked me in. But I want to reflect on you started with Solid, which for listeners who maybe aren't familiar with this from a software engineering perspective, and I'm going to go down this list and it's not going to be fun. I'm sorry, listeners, but we got to do it because I'm going to show you the contrast. Single responsibility principle. We talked about that one a lot. It's easy to understand. Open close principle. I don't have time to explain it right now, but Liskov substitution principle. I definitely don't have time to explain that. Interface segregation principle and dependency inversion principle. So, for hardcore software engineers, we're going to go, yes, this sounds great. But I do think that the computer science world sometimes doesn't translate well into a design context. And when you're just looking at designing something, it's designing a platform in particular, you need a set of principles that are understandable that everyone can kind of grok, not just the software engineers. So I love these kinds of efforts. There's been a lot of them out there, um, but it's why like one of my core ideals is like principles, not frameworks. Like don't give me a rigid structure because every place is different, right? And I'd imagine you've
Yeah.
been in enough different shops to know this too.
Yeah, yeah. Every place you come across has a different way of doing it, and it is definitely that if you have specific rules or principles and you try to apply them, they probably work the first time you build the software because it's nice and clean. But then, as soon as you then try and expand the software, maintain the software, add new features into the software, you get into this horrible world of, well, do I break the principles to achieve what I want to do, or do I spend much longer ripping everything apart to insert all the new stuff and maintain the principles again? Which is why sort of something like Cupid, which takes much more sort of, it's a property, it's not a rigid thing, it's kind of a guideline. You should be aiming to try and get to the better end of the guideline, but it accepts you're not there at the moment.
Yeah.
And then you move in that way. It makes your life building the software much easier, having those guides, but not sort of an absolute rigid set of things that you've got to follow.
Yeah, every platform project I've ever worked on, it inevitably becomes a thing as like, what are our principles? And I feel like it's kind of like a social contract exercise where it's not so much what you end up with. You could have anything from kindergartners to executives. The list looks pretty similar in defining a social contract between a group, but it's about having the discussion and really embracing ideals for yourselves. But I feel like this is a fantastic starting point, and I definitely want to dig into it. So thank you for sharing it.
Excellent. Very pleased to.
Well, Chris, I appreciate you having given some of your very valuable time to us here. In closing, and if you've ever listened to the podcast before, you'll know this is coming. But we just talked about a whole lot of stuff that for someone who's just, kind of setting up to look at the self-evaluate their own situation might go, that is overwhelming. Where do I get started? What do you think is the most kind of valuable thing to embrace to start turning a corner on either transformation or kind of starting from scratch?
I'd probably go and look. Definitely the Cupid site, because that just gives a good outline of that. And there are lots of sort of really good sort of starting tutorials on domain-driven design. So that's a good point. I've kind of like tried to summarize those a little bit in my blog post, so you can potentially hunt down those as a reading point, as a sort of starting point. I've tried to keep them sort of not at a too technical level. But yeah, I would definitely start having a look at just touching into the domain-driven design, because there's a few basic concepts like creating a ubiquitous language that the business understands,
Yep.
separating stuff into those separate concerns. Just start playing around with some of those ideas, and then the rest kind of you can build on gradually after that.
Yeah. So you tried to plug yourself there, but you got to tell us where do we go to find your things that you write?
Okay, that's on my blog, which is software.skipoles.co.uk.
Nice. Well, Chris, thanks again for coming on and giving us a little bit of a grimier, hands-on view of the world. But I have to say, it's not really probably that much different than the typical management types we get on here. But either way, thank you so much. Thanks for listening. If you have a question you want to ask, look in the description of whichever platform you're viewing or listening on, and there should be a link there so you can go submit a question, and we'll do our best to find out the right answer for you.
API Intersection podcast listeners are invited to sign up for Stoplight and save up to $650. Use the code INTERSECTION10 to get 10% off a new subscription to Stoplight Platform Starter or Pro. Take a look at this episode's description for more details.